Hey, welcome to another edition of Black Butte Forge. I'm Arnie. Want to start this video off first by saying thanks a lot to all the new subscribers. I really appreciate it. Thank you very, very much. Next project is going to be setting up to forge these handrail returns. There'll be a post here. Return is what you grab heading up this flight of stairs. Kind of a proprietary design that my mentor created, and I continue to do the work and pass it on, keep it out there. Anyways, last video I showed you how I did, before I show you this, I wanted to talk a little bit about the safety about this setup here before I take it all apart while it's still here in the hammer. I talked about the fact that the breakage happens here, and I talked about the fact that I use a chain to minimize the breakage, and that I welded everything up with arc welding rod that's 110/18. So what I didn't really do is kind of describe why I did all of that stuff, or for example, like why back here this is riveted together instead of just welded, or for example, why I don't make the traditional style, which looks a lot like this. This is how it evolved. At our shop, we started learning like this, and eventually we started riveting everything. So real brief, what I want to do is explain this. Everything here is actually made out of mild steel, with the exception of the die itself. Okay, so this is a single face setup with a flat surface. Okay, so without taking it apart, I could show you. This is what I would use for double facing. This replaces that. Okay, so I've got all these hammer faces, and that's what this looks like under here. This is a piece of leaf spring from a semi truck. Okay, however, these components here are just mild steel, and as you can tell, it's pretty heavy. It's all 1 inch. One thing you got to remember about a power hammer is that the vibration of everything, each time it hits, the shock is attacking the welds. It's attacking the rivets. It's attacking anywhere where the metal turns and bends upon itself or anything like that. So that's why 110/18 is it. So you're looking for this. You're looking for the 1, the 110, and 18. What does that mean, right? So 110/18 basically means this in the world of welding, for those who don't know, okay? The first numbers in welding here on the welding rod represent your tensile strength, okay? In this particular case, it means that if the rod is going to have 110,000 pounds of tensile strength of shear, more or less, which you can think of that as in terms of it takes 110,000 pounds to go like this, or it takes 110,000 pounds to go like that and shear it, okay? So roughly that's what you're dealing with. What does the 1 mean? The 1 means it's an all-position rod, okay? This number is going to be either a 1, a 2, a 3, or a 4, okay? 1 means it welds up, down, left, right, diagonal, doesn't matter, right? Does it all. The number 8 in this particular situation means it's a low hydrogen rod, okay? It means that the flux around the wire is designed to absorb as much hydrogen out of the air as possible, because hydrogen inside the weld puddle is an enemy. Creates stress, creates cracks, creates all kinds of problems. So the 8 is going to be the welding characteristics and or chemical composition of the welding rod. And oftentimes, rods that have an 8 as the last number will also have a certain percentage of iron filings in the flux. So for example, like the rod I'm holding here is piece 7018. This will have like 30% iron filing in the flux, like ground up steel. All right, so I use the 110 instead of the 7018 because the hammer always wins. And that's the thing you have to remember about working with a tool like this, is this thing will win every time, okay? It's dangerous. There's a reason why we don't make everything out of steel with a tool 120 years, ago that was prevalent in every shop. It's because men died using this tool, okay? So to make it as safe as I possibly can, I've done certain things. Number 1, I weld all of this stuff up with 110/18, okay? It absorbs the shock better than 70/18, better than 80/18, better, okay? And the parts live longer, okay? So, another thing too, I rivet together. I prefer to rivet for the same reason that they prefer to rivet the frame on the car, for the same reason they prefer to rivet the bridge together. It's just a better attachment under a very high stress situation. So, another thing too, as I mentioned, this is a leaf spring, okay? This is a very high carbon tool steel. This is mild steel. As you can tell, the weld keeps breaking at the mild steel. That's why there's a row of beads that comes back here, okay? So that's telling me that the stress happens right there every time. It just keeps breaking right there, all right? 110/18 is the right choice because this is a leaf spring and it's not breaking against the leaf spring. It's breaking where I want it to break at the mild steel joint, okay? So, another thing too, before you weld all this stuff together, what you do is you shape your hammer face, you put all this stuff together, and you get this die a light red color out of the forge. You bring it out as a light red color after you've already done all the work, and you weld this while it's a dull red. And that also helps get that first bead to take really, really well. Okay, the chain, as I mentioned, the chain actually does relieve a lot of the stress, because what tends to happen with a slapper die is they just, this arm will fly up in the air, the hammer will hit it way up in the air, and it smacks it before it's actually in contact with the metal you're trying to texture. That's a smack and then a smack again. So without the chain, it's literally hitting it twice. And there's 2 times it shocks per every blow. So the chain helps it cut that in half, literally in half, all right? And therefore you're gonna get half the breakage. Another thing I didn't show up close, okay? If you look closely right here, you'll see a little bit of a yellow spacer. So what these are is I'll put a spacer in there, and that'll allow me to keep this flatter for, say, working 5/8 material, which is the last thing I did in there. I could throw a 1-inch spacer in there, and then that keeps that flatter for 1-inch material as well. And I'll even do 2x2 solid steel posts in here. After that, we use a bigger hammer. So the spacer is a trick, keeps it level, and it also keeps you from working forging the steel where the top die is hitting it at a poor angle, thus causing more stress here. That's going to cause that to break. Okay, so just remember, whenever you're building these types of tools out of the power hammer, never MIG weld it. Never use one of those Campbell and Hausfeld little flux-core welders that you can get at the hardware store. Don't do that, okay? Because those types of machines were never made to weld anything structural that this hammer is gonna, try to destroy, all right? And as I said earlier, the hammer always wins. So good luck as you guys get out there and create your own tooling for your hammers and trip hammers and whatever things you guys are buying, so that you can pursue your hobbies in blacksmith. But just always remember, as you make these tools, arc weld them up. If you're using carbon steel, preheat that die before you weld it. That's basically my best advice. When you are creating dies of this nature, you want to minimize that slapping, and that'll improve the life. So I hope these little tips help you out and help you be safer. And I hope that with whatever your blacksmithing endeavors are, you actually end up with less breakage and all your tooling lasts longer as a little bit of result of this helpful advice. So again, I want to conclude this video by saying thank you very much to all the new subscribers. There's actually commercials on the video now, so wow, thank you very much. And I'm going to get to changing out these dies. We'll get on to setting up the camera so we can show you how to forge, or how I forge those handrail returns that I showed you at the beginning of the video. Thanks for tuning in. If you like what you saw, press like. If you also liked what you like, share it with some of your other blacksmith friends and pass on these trade secrets. All right, thanks for tuning in. Welcome. Have a good afternoon. Until next time, thank you very much.